Okay, let's take a look at the characteristics or attributes of quadratic functions. We're going to look at it from two angles. The first is from the point of view of a graph. Now, every graph of a quadratic is a parabola. They're always U-shaped, opening up or down. Every parabola has a vertex. Every parabola has a y-intercept. And finally, every graph of a quadratic or parabola has an axis of symmetry. It is a vertical line splitting the parabola in half. Pause now and make sure that you have each of these four attributes of a graph, of a quadratic, and a sketch of the graph. Now we're going to look at how you identify the vertex, the y-intercept, and the axis of symmetry if you're given a graph. Okay, now I'm going to take a look at this graph, and I can see that the high point, or the vertex, is located at x equal -4 and 7. Now, once I know that, then I can look at my y-intercept, and that is where it's going to cross the y-axis. X is always 0 there, so it crosses at y is equal to -1. And finally, my axis of symmetry is a vertical line that runs straight through at the x value of my vertex. So it's x equal -4 because that's the x value of my vertex. Pause down and write down this example and make a sketch of this graph. Now, we're done looking at it from a graph point of view. Let's take a look at it from the point of view of equations. Now, linear equations have several forms: the slope-intercept form, the point-slope form, the standard form. Likewise, quadratic functions have two forms that we're going to study here. We're going to study the standard form and the vertex form. The standard form is f of x is equal to ax squared plus bx plus c. The vertex form is f of x is equal to a times x minus h squared plus k. Pause down and write down these two forms and make sure you label the standard form and the vertex form. Now we're going to start by looking at the standard form. You should be very familiar with this. This is the form you probably studied in Algebra 1. Well, what can I tell using the standard form? Well, I can tell whether or not the parabola opens up or if it opens down. If A is positive, it opens up. If it's negative, it opens down. I can also tell the vertex. Now, to determine the vertex using this form, I'm going to need to use a formula which is -b divided by 2a. Let me repeat that. -b divided by 2a. Now, you need to know that particular formula like you know the back of your hand. So make note of that, and we'll look at an example of how to use that. Once I find that value, -b over 2a, I'm going to plug that back in to f of x. And everywhere I see x, I'm going to substitute -b over 2a to find the y value of my vertex. I can also tell the axis of symmetry. Its equation will be x equal -b divided by 2a because it's a vertical line that runs directly through the x value of my vertex, and in that case, that is -b over 2a, whatever that ends up being. And finally, c is always, always, always the y-intercept of my quadratic function. Pause now and write down these four attributes of the standard form of a quadratic function equation. Now let's look at an example. First of all, let's ask the question, does this graph, represented by 2x squared minus 4x plus 5, open up or down? Well, a is 2. That is definitely greater than 0, and so this graph opens upward. Now let's go ahead and find the axis of symmetry. Now, the axis of symmetry is given by this formula. X is equal to -b divided by 2a. Well, in this case, b is -4. And so I'm going to substitute negative 4 in for b. A is 2. I'm going to substitute a in for 2 and solve for x. X is going to be equal to 1. And so my axis of symmetry is the equation x equal 1. That also tells me the x value of my vertex. Now that I know that, I can use that to find the y value of my vertex by substituting in 1 for x. Every time I see x in the original equation, I had 2x squared minus 4x plus 5. So now I'm going to have 2 times 1 squared minus 4 times 1 plus 5. And so everywhere I saw x, I substituted in 1, and then I'm going to determine the value of that expression, and it ends up being 3. And so my vertex is at 1 and 3. X equal 1, y is equal to 3. And finally, I can find my y-intercept just by looking at the value of c. C is 5, and so my y-intercept is located at 0, 5, or y equal 5. Let's take a look at another example. In this case, A is negative 1, B is 3, and C is negative 1. Now, I know that this graph opens downward because A is negative 1, and that is definitely less than 0. To find the axis of symmetry, I'm going to go back to the formula. X is equal to negative B divided by 2A. Well, B is 3, so I'm going to substitute that in for B. And A is negative 1, so I substitute that in. And I'm going to end up with 3 over 2. Now I'm going to take my value 3 over 2, and everywhere I see x in the original equation, I'm going to substitute in 3 over 2. So I have negative 3 over 2 squared plus 3 times 3 over 2 minus 1, and I end up with 5 over 4. Now you'll be doing most of this calculation work with calculators, so don't worry too much about that. And finally, the y-intercept is negative 1 because that's the value of c. Now look, sometimes you can just graph a quadratic, and if the vertex is at a nice round number and it's a small enough number that you can see, like within a window of 15, then you can just graph it and find the vertex and find the axis of symmetry and do all of this. But many, many times your vertex will be a fraction or a decimal, and you'll need to know how to do this algebraically. Pause now and write down this example. Now, let's look at how we can use these attributes to help us graph. So we have this function, f of x, or y, is equal to negative x squared minus 2x plus 3. Okay, I'm going to start by finding my axis of symmetry. B is negative 2, so I substitute that in. So I have negative b divided by 2 times a, which is in this case negative 1. That gives me negative 2 over 2. I end up with x is equal to negative 1. And so I graph this vertical line at x is equal to negative 1. Next, I'm going to find my vertex by substituting negative 1 back into the original equation and solving for f of x. It ends up being 4. So I know my vertex now is at x equal negative 1 and y is equal to 4. And so I'm going to plot a point there. The next point I plot will be at the y-intercept. I know that's at 3. Right here, x equals 0, y equals 3. That's my y-intercept. Now I'm going to use the principles of symmetry to help me complete my graph. Now here's the axis of symmetry, and I notice that the y-intercept is 1 unit away. That means 1 unit away in this direction is another point. I can plot that point, and now I have 3 points. I can complete my graph. Pause now and make sure that you have all of the points in this example along with the sketch of a graph. All right, now let's take a look at the vertex form. The vertex form should look familiar to you because it's very similar to the vertex form of the absolute value function. Only there we had bars and we didn't have the square. Now we have parentheses and x minus h is squared. Now, what can you tell from the vertex form? Well, first of all, A, just like the A in the standard form, tells us whether or not it opens up or down. If it's positive, it opens up. If it's negative, it opens down. H and K, you know, tell you the vertex. They told you the vertex in the absolute value function, and it's the same here. H and K, vertex. And finally, because you know H, you also know the axis of symmetry. It is x equal h. It's always x equal whatever the x value of your vertex is. Pause now and write down these points about the vertex form. Okay, now let's talk about how you might use the vertex form. I've given you a vertex form of a quadratic right here. We have negative 1/2 times x plus 5 squared minus 8. Okay, so let's discover h and k. Now here I have rewritten this equation to find the value of h. And I found that it was negative 5. But you could just remember that x plus 5 means that 5 is negative. So it's negative 5. I've gone back to the x minus h form here. So if h is negative 5, I'd end up with x plus 5 because of I'd have minus negative 5. But let me go back. So h is negative 5, k is negative 8, very straightforward. And so my axis of symmetry is x equal negative 5 because h is negative 5. And my vertex is negative 5 and negative 8. Pause now and make sure that you have all of the important points of this example. Let's look at another one. I have here x minus 3 squared plus 1. A is greater than 0, so I know this one's going to open up, and we see a graph here. It does open up. I can also determine that because I have x minus 3, the 3 is positive, so my axis of symmetry will run right through 3. The equation is x equal 3. And my vertex, by the way, is positive 3 and positive 1. Pause now and write down this example. Now, a couple of things I want to cover with you before we finish. One is that if the parabola is opening upwards, then the y value of the vertex represents a minimum value. On the other hand, if the parabola is opening downwards, then the y value of the vertex is a maximum. Pause now and make sure that you have pretty much everything on this slide. So what does that mean? We're going to find the minimum or maximum of this function, negative 3x squared plus 2x minus 4. Well, we got to determine whether it's a minimum or a maximum. This one is opening down, so it's a maximum value. I'm going to find my maximum value by first finding the x value of the vertex. I do that by using the formula negative b divided by 2a, and my value ends up, the x value of my vertex ends up being 1/3. And then I'm going to substitute 1/3 back into the original equation and determine my value for y of my vertex, and it ends up being negative 11/3. Therefore, the maximum value, which is always the y value of the vertex, is negative 11/3. Pause now and make sure that you have this whole example copied down. Now, I'm sure there must be questions, and I want to make sure that you write down your questions on your notes and bring them to class, and we'll get all of your questions answered. I'll see you in class.